So with this video, we're going to spend some time figuring out how to calculate density. One of the important things about this is that we also want to think about how our units tie into these calculations. Because from an algebra perspective, the density formula is actually quite simple. But if we're thinking about in a science class, we always want to do our math with units so that it makes sense. There's just another layer that we need to think about here. So if we look at this first problem, what is the volume of a 3.45 gram sample of pure silicon? The density of silicon is 2.33 grams per centimeter cubed. Before I start plugging in numbers into my formula, I'm just going to figure out what I have. So I'm going to look at this problem. The first value I run into is 3.45 grams. Now my job is to figure out which variable, density, mass, or volume, this value fits into. And the way we tell that is through our best friend, the unit. Grams are a unit of mass. So if I know I'm in units of grams, I know this is my lowercase m. This is the mass variable in my density formula. We're also given this value, and the problem tells us that this is density. But if the problem didn't tell us that, we still would be able to tell. Because this derived unit here, a mass unit divided by a volume unit, is the unit for density. So we know that that's density. Which means that the problem is asking us to find the volume. That's my unknown. So now I'm going to substitute in my values. My density is 2.33, and actually I'm going to move this a little bit. 2.33 grams per centimeter cubed. And that equals my mass, which is 3.45 grams, divided by my volume, which is still unknown for now. One thing we need to be careful of here is you might think I can divide both sides by 3.45, and that's going to give me volume. Careful. If you do that, you won't get volume. Instead, you would get 1 over volume, the reciprocal of volume. That's not what we want. We don't want the reciprocal of volume, we want volume. So my pro tip, if your variable is in the denominator, multiply so that you can get it in the numerator. So now my volume on the right side of the equation cancels, and I'm left with 2.33 grams per centimeter cubed times my volume, my unknown volume, equals 3.45 grams. Now my volume is not in a denominator, and now I can divide both sides by my density to isolate my volume variable. So these will cancel. I'm left with volume on its own. And I will put this into my calculator. 3.45 divided by 2.33. And that will give me 1.48, about. I'm rounding. We need to think about what our units would be. Now you can just think about what a unit of volume would be, and then you would end up with centimeters cubed, and you would be correct. And that is our answer. But if you really want to think about letting the units be your guide, look at the algebra that we've done here. My units of grams cancel out because 1 is in the numerator and 1 is in the denominator. If I were to simplify this statement, I would end up with 1.48, 1 over centimeters cubed. The phrase I use, the enemy of my enemy is my friend. The denominator of a denominator is a numerator. So here, centimeters cubed is in the denominator, and 1 over centimeters cubed is also in the denominator, which means that I end up with units of regular old centimeters cubed. Now, if we look at the next problem, we're going to follow the same set of steps. What is the density of a 5.00 gram sample of tungsten that has a volume of 0.26 centimeters cubed? First thing I'm going to do is my bookkeeping. I'm given this value, 5.00 grams. I know that this is a mass because my units of grams. Grams equals mass. The next value I have is 0.26 centimeters cubed. Now the problem tells us that that's a volume, but we also know that because centimeters cubed are units of volume. From here, I'm going to plug in what I know to find what I don't. I don't know my density. I do know my mass. I'm going to plug that into my formula. And I do know my volume. Lucky for us, our unknown is already isolated, which means I can put this straight into my calculator. And that's going to give me about 19.2. My units, of course, are derived units for density, and they're going to be grams per centimeter cubed. Because what was the math we did with our units? We took grams and we divided them by centimeters cubed. And we see that show up in here as well.